Review video number 4, electric power. Consider the figure at right containing a single battery and one resistor. In terms of V and R, write algebraic expressions for the current through the battery. Well, the current through the battery is going to be the voltage of the battery divided by the resistance felt by the battery. The current through the resistor, same thing, V divided by R. The power, recall that electrical power is I times V. The power consumed by the battery, if the current of the battery is V over R, if I put V over R in here, then do you see I end up with V squared over R when we multiply by that R. And that's what we're going to get over here. Same idea, V squared over R. And that makes sense because the power delivered by the battery should be the power consumed by the resistor, and that's what we have here. Now, suppose we have the same basic circuit, except we've added a second resistor here in series, which means that the equivalent resistance, the resistance felt by the battery, is 2R, R plus R. Those resistors are in series, so we find the equivalent resistance by simply adding them. Current going through the battery is the voltage of the battery divided by the resistance felt by the battery, which is 2R. That current has to be constant throughout this circuit because there's only one path. So the current that's going through each resistor has the same expression there. The power consumed by the battery is I times V. If we put that I in there multiplied by V, we essentially get V squared over 2R. What about the power through each resistor? All right, so should I put each here? Each resistor. The voltage for each resistor is only half of the voltage of the battery. So the voltage of each resistor is only 1/2 of the battery voltage because the voltage drops halfway and then it drops the other half of the way. When we do power is equal to I times V, we have to take this I and this V right here. So I'm thinking that that's going to be V squared over 4R. And look at that. Since you have two resistors, you have V squared over 4R. You double that, and that's going to be the power that's being delivered by the battery. All right. What if now we take the same resistors, but we put them in parallel instead of series? Well, when we put them in parallel, then we have to use the 1/over equation to find the resistance perceived by the battery. So that would be 1/R plus 1/R, which is 2/R. Take the reciprocal of that, that gives you 1/2 R. This is the resistance that the battery perceives. The current that's going to go through the battery is going to be the voltage of the battery divided by the resistance that the battery feels, which is going to be 2V over R. Now that current is going to split 50-50 if both of these values of R are the same. That current is going to split half and half here. So each resistor will have a current of just V over R. 2V over R splitting 50-50 is V over R each way. The power output by the battery is the current going through the battery multiplied by the voltage of the battery. Isn't that going to give us 2V squared over R? The power from each resistor is going to be the current going through each resistor multiplied by the voltage across the resistor. Well, the voltage across the resistor, you see, if we color code this, you see that the voltage across each of these resistors is numerically equal to the voltage across the battery. See, because the colors across the battery and the color difference across the resistors is equal. We're going to go V divided by R multiplied by V. So that's just V squared over R. And one more time, if you take the power consumed by each resistor, there are two of them, isn't that equal to the power delivered by the battery? Okay, so to summarize what we did here, which one had the greatest battery current? Let's look at our answers here. For this case, we had V over R. This one was 1/2 V over R, right here where I'm pointing, and then this one was 2V over R. So the one with the greatest battery current was when we had two resistors in parallel. Which one had the greatest total resistance? Well, we don't even have to look at the diagram for that, do we? Two resistors in series is definitely going to have the greatest resistance. And which one's going to have the greatest power usage? Well, the greatest power usage is going to be the one that has the greatest battery current. Two resistors in parallel.